Hello everyone, I'm Thijs, I'm the technical evangelist at Varnish software, and welcome to another VMOD in the spotlight. This month's VMOD that we are putting in the spotlight is Brotli. Brotli itself is a lossless compressed data format that is invented by Google. It's similar to gzip, and in our context, its primary domain of application, just like gzip, is to compress HTTP responses over the wire. Browsers advertise the compression formats they support through the accept encoding header. In this case, gzip, deflate, and BR are supported. BR happens to be short for Brotli. When the server inspects this header and decides to compress data using Brotli, it also advertises this using the content encoding header and adding the BR value. If it turns out that the client supports Brotli, but the server doesn't, another compression format will be selected. So the backup could be gzip. But if no compression is supported, no content encoding header is used, and the plain text data is sent to the client. Why would you consider using compression for HTTP? The answer is very straightforward. By compressing HTTP responses, you send less data over the wire. This means it takes less time to load it, so latency drops, and that results in an overall improvement of data transfers. So why do we want to use Brotli? Why not stick with gzip that has been doing a very good job over the years? Well, the compression algorithms that are used by Brotli are more efficient than gzip, so that results in better compression, which means smaller packets over the wire, which means less latency. In terms of speed, they're on par as well. It takes as much time to compress and decompress using Brotli than using gzip. And browser support is getting very decent. So if you want better compression over the wire, Brotli can be a very good option. With all that being said, let's talk about the VMOD now. VMOD Brotli is part of Varnish Enterprise, and using it requires writing some VCL. To get started, import the Brotli VMOD and initialize it using the brotli.init function that can be called within the VCL init subroutine. The function has some function arguments that can be used to configure the behavior. The first argument is the encoding argument. It defines which accept encoding values are supported. By setting it to both gzip and BR are supported. Alternative values are gzip, BR, or none if you don't want to accept any accept encoding values. The second argument enables or disables transcoding. By default, the transcoding argument is set to false. By setting it to true, you're basically making sure that if an origin server sends gzip content, it will be transcoded on the fly to Brotli for clients that support Brotli. And the other way around. If Brotli content is received and stored in cache, it can still be transcoded into gzip for clients that only support gzip compression. However, if gzip content is stored in cache, it will only be transcoded to Brotli if the accept encoding header only supports Brotli. If the accept encoding header presents both gzip and Brotli, the stored format will be preferred, which in this case is gzip. Let's visualize the transcoding with a diagram. It all starts when the first client connects to Varnish, sends an HTTP request, and advertises its Brotli support through the accept encoding header. Varnish doesn't have the object stored in cache and needs to connect to the server. It forwards that very same accept encoding header that it received from the client. The server notices this and happens to support Brotli and sends a Brotli encoded response back, while advertising this using a content encoding BR value. Varnish stores the object in cache and delivers it back to the client in the requested encoding format. Meanwhile, another client that doesn't support Brotli but only supports gzip sends a request for the very same resource. That is cached by now. But because we initialized Brotli with both accept and gzip as accepted values, and because we enable transcoding, a gzip encoded format, or gzip transcoded format rather, will be sent to the client. If we initialize the Brotli VMOD by only accepting Brotli as a valid accept encoding value, and by not enabling transcoding, the situation will look slightly different. Have a look at the following diagram. While the flow for the first client will be identical to the previous example, the situation will be very different for the client that only supports gzip. Because we configured VMOD Brotli in such a way, we will not support gzip as a valid accept encoding format, and we won't transcode the object. This means no encoding will take place and an uncompressed plain text response will be sent back to the second client. Because the accept encoding header that is presented to the origin server depends on the initial request, your mileage may vary. To make sure you have a consistent experience, you may override that accept encoding header, and that can be done using the brotli.accept function. It accepts a value, and by setting it to both, as you can see in this example, the accept encoding header will be overridden and BR and gzip will be presented to the origin server. Even though we just overrided the accept encoding header prior to performing the fetch using brotli.accept, you may still end up with gzip compressed responses or uncompressed responses, depending on the capabilities of your origin system. And as you can see in this example, when the response that was received from the origin contains gzip in its content encoding header, or it's uncompressed and is just plain text, we will override this behavior by calling brotli.compress to ensure that the object that is stored in cache is Brotli compressed. This all-in-one VCL example is the perfect foundation to get started with Brotli. I hope you enjoyed the video. I'll be back next month with yet another VMOD in the spotlight.